So let's take a look at this problem, the bagel store problem, which is the 3.5 in the 5th edition of Cachon and Terwiesch. So it looks like a pretty interesting problem. So consider bagel store selling 3 types of bagels. So we know that we have a multiple flow units. According to process flow, we assume the demand is 180 bagels a day, which there are 3 grilled veggies and 110 veggies and 40 cream cheese. Assume that the workday is 10 hours long, okay, 10 hours long. And with each resource is a step with a 1 worker. So this is our process time. It looks like even though the flow units are 3, grilled veggie and cream cheese, they're all considered by bagel. So each resource have the same capacity or same processing speed on whatever type of bagels that it's dealing with. In a sense, it's a much simpler problem than your Q3.2 problem, where it's multiple resource, multiple flow units. Resource have different processing time on, different type of flow units. So I think the first question is asking which one is bottleneck, right? The second one is how many units can the process produce within 1 hour, assuming the product mix has to remain constant. Okay, it's a similar problem. So let's first try to identify the bottleneck. So bottleneck have many different ways of identifying it, but chapter 3 approach is basically using the implied utilization, which is the ratio between what is it? The ratio between workload and capacity. Okay, so to be more specific, the workload is our lambda and the capacity is our kappa. Okay, so we're gonna find it out for each one of those process here. Okay, and we can get the implied utilization on each of those resource, and we can actually identify which one is the bottleneck. Okay, so since it's not that complicated, I'm just gonna use the drawing here. So let's go with a drawing tool. So grilled veggie, let's see. So it's a day, right? It's a day. So I'm trying to determine what time unit should be used for the analysis. Okay, so I'm actually going to take 2 different approaches as my previous example. The first approach, I'm going to be using the number of bagels each hour as the flow unit, and I will also demonstrate when I use each minute of work as the flow unit. You can basically pick whichever approach that is more intuitive to you. To me personally, I think for this particular problem, the number of bagels as the flow unit is going to be more intuitive. So I'm going to solve that first graphically. Graphically means I'm just going to annotate here. So for this cut process, my lambda is I think it's actually total lambda is 180, because 40 here, right? I'm just going to write it down. 40 here. No, it's not 40. It's a 30 here. Okay, let me do it again. It's a 30 here for grilled veggie, and for the veggie is 110, and the cream cheese is 40. So in total, your lambda is 180 in that way. And I'm going to come back here later to figure out what is the kappa. And here to put grilled stuff on bagel, only the grilled veggies are going here. So it's going to be 30 here. So the 30 will come here to join with 110. So you're looking at the lambda of 140 here. So the purple is my lambda here, okay? For the cream cheese, it's only 40, right? Only 40 here all three merged together here. So you're looking at 180. Yeah, that makes sense. So now we have all the workload or our lambda calculated. Now it's time for us to calculate what is the capacity. What is the capacity? So I think this may require a little bit of calculation. So instead of just trying to draw it, I actually need to run the number for now. So for cutting grilled and veggies and cream cheese. This is a resource. This is not the bagel type. And wrapping. So given the information here, 3, 10, 5, 4, 2. Those are minute per bagel, right? Minute per bagel. Oops, where did I? Okay, wow. Okay, here, and my this is daily. So my per day, right? Let me go with hour first, and then I'm gonna translate into per day. So each hour, you got 60 minutes, right? 3 minute per bagel. So that's your hourly capacity. That's your hourly capacity, and then you multiply it by 10. That will become your what? That will become your daily capacity for each of those resources. So you're saying 200 here, 60 here, whoops, 120 here, 150 here, and 300 here. Yeah, do they have same number of worker in each process? Yeah, step with one worker. So I guess this is gonna be their capacity. So it's gonna be your kappa, right? So since we have a lambda or workload already calculated here, let's just write down here. This is also per day, okay? It's cut, we have 180. For grilled, we have 30. And the veggies, we have 140. And cream cheese is 40. And it's 180, right? So your implied utilization is basically lambda over kappa. This is what we have now. This is our situation. So let me, okay, this is our situation. Obviously, the veggies is going to be the bottleneck because your workload is 140, but your capacity is 120. So you can only deliver up to 120 per day because veggies is going to be your bottleneck step, bottleneck resource. So this is underutilized. This is also heavily underutilized. I'm pretty sure that there's something you can do about this. If you are the actual manager of the store, this is going to be the basis for the adjustment. So let's take care of the question B before we move on to finish this whole thing. So I'm sorry I didn't actually use orange color to draw the capacity part, but we've done it here. Okay, so I guess this is straightforward enough that we don't really need to make any big deal out of it. So it's basically saying you want to maintain the same ratio in the previous problem. Okay, so you are grilled veggie and veggie bagel and cream cheese bagel. The ratio is 30, 110, and 40. This is the ratio. So again, to get the ratio is for let me see. For each unit of grilled veggie, you want to make this many. For each unit of veggie, you want to make 3.67 unit of veggie. Okay, did I say it right? For each unit of grilled veggie, you want to make 3.67 units of veggie bagel. For each unit of grilled veggie, you want to make 1.33 units of cream cheese. So again, the same way, if you want to use the veggie as the basis. So for each unit of veggie, you want to make a fraction of cream cheese. Okay, so again, let me just go ahead and finish. For if you're using cream cheese as a basis, because it wasn't clear to me here which one was the which bagel is gonna be capped. Okay, so that's why I'm just thinking out loud here. Those are actually all the same ratio. So let's see. Which one is actually get capped? Meaning which one is actually get bottlenecked? So it took a minute to think about this, because 140 will have to be lowered to 120, right? Because it's the bottleneck. So whatever being processed here will needs to be reduced by certain percentage. Okay, certain percentage. So in this case, I don't know if you can actually follow what I'm doing here. So now the veggies on bagel step here, you are basically short by 17%. Okay, 17% here, 17%. So you're looking at reduction of certain percentage on both items here, both the grilled veggie and veggie. Okay, so what fraction of 140 is 120? Okay, so 140, 120. Okay, I'm just thinking the process. So obviously you're looking at certain percentage that is less than 1. And once we obtain this percentage, then we can apply to here, and then in that way we know exactly how much to reduce here as well, so that we can maintain the same ratio. So the X is basically 120 over 140. Hopefully I'm getting this right. So you need to reduce only like 86% of your demand will be fulfilled because of the capacity in veggies on bagel. So this one here, I think your flow rate, because we want to maintain this particular ratio, so our actual flow rate, given we can only fulfill this much because of the bottleneck here in veggies on bagel, it's gonna be 30 multiplied by this percentage. Okay, I'm gonna static reference this, and then I'm gonna apply the same percentage to all of here. So I think you can't really make a fraction of a donut. So in that case, I will take the floor, which is integer, not the next integer, but the previous integer, which is 25 here. Do we have a floor? I'm not sure whether this is the job. Let's see. Okay. Yeah, it's taking the not the next integer, but the previous integer. So 25, 94, 34. they don't add up to 120, but if you take a bigger integer, it's going to exceed 120. So this will be basically my approach. So again, given that veggies on bagel being the bottleneck, we have to let go of some workload. Basically, we can only fulfill 86% of the workload. We need to apply the same percentage here, here, here. This is what we have. Okay, flow rate. This is the flow rate. I don't know, you can supply those to your Connect to see whether they accept it or not. But in real world, I would take the smaller integer than the bigger integer. Otherwise, this will exceed the capacity. So this is the my approach when I'm using the number of bagels as the flow unit. Yeah, I did mention that we can also take, what is it? We can also take the minute of a minute of work as the flow unit. So I think in that case, this is also it's also it's also very doable. So let me see. I also need to calculate the capacity. I'm sorry, kappa. 3 minutes per bagel, because we have 10 hours per day. So it has nothing to do with that, right? So if you're taking that per minute of work as the flow unit, I think in this case you have 600 minutes, because each hour you have 60 minutes. Then we have 10 hours here, right? 10 hours here. And all of them will have equal amount of minutes. And then it's our workload analysis. Workload, okay, workload. For cutting, because we calculated here, for cutting you have 180 demand by unit, okay, 180. And for grilled part you have 30, and here you have 140, or 40, and here's 180. The process time is 3 here, 10 here, 5 here, 4 here, 2 here, regardless of type of your bagel. So your lambda here is basically multiplication of process time and the demand. Okay, this is a number of minutes per day. This is also number of minutes required per day. So with that, I think our implied utilization is going to be the same with our previous result. Okay, that's it. It's going to be the identical result. So because the result is identical, you can take the same approach to figure out how to maintain the ratio by respecting the bottleneck. Okay, that'll be it.